This is part 2, family-owned production takes on Zero Net Energy, and this is the second part of our Zero Net Energy Builder Innovations webinar series. We're fortunate to have Brandon D. Young here, Vice President of Ops at D. Young Homes. So we're enthusiastic that he's here, and he's got a great presentation lined up for you. So as usual, this webinar is made possible by our generous sponsor, Pacific Gas and Electric Company. Though Brandon's comments won't be affiliated with PG&E, they do fund our webinars and make it possible to offer this for free for all of you. So big thank you to them. Just so you can navigate your way around here on the control panel, here are a few important items: collapse, full screen, the hand icon. We probably won't use the hand icon so much, but do use the questions pane. The way that we're going to run questions in this webinar is have each person, if you have questions, go ahead and type it into the questions box, and I will be looking at those throughout the presentation, but we will keep them until the end so that Brandon's presentation so that we can get all the way through. As we are starting a little bit late, I'd like to ask folks to stay on the line just a few minutes late. You know, I know that we've all got things to do, so my apologies for that again. And right now, if you can't hear me, please do raise your hand so I know if we're experiencing any issues. All right, also if you're experiencing any sound issues, you may want to try calling in using a landline telephone. We know that sometimes using the audio through the computer can be troublesome. You can get an echo, so if you're trying to resolve that issue, go ahead and try it on a phone line. Just a little bit about Build the Green, and I'll keep this brief. We're a nonprofit organization with a membership base ranging from contractors to real estate professionals to homeowners to consultants. We're here to support you guys. Any information you need about green building, we want to provide it, and we love hearing your feedback, and we want to know what topics interest you. We host a couple of conferences every year, webinars every month, and several types of trainings, including the trainings for our Greenpoint Rated program, which is a home labeling system. So for more information about that, you can go ahead and visit our website, www.builditgreen.org. And about the webinar today, we will be giving one Build It Green continuing education unit for those of you on the line who do have a Build It Green certification. We'll automatically attribute that to your profile. And for more information about how you use that CEU, you can look at our recertification page online. Like I mentioned before, this is the questions box. Go ahead and type anything in. We'll gather questions at the end. And now I'm going to hand it over to Shilpa Sankran, who is with the Net Zero Energy Coalition. We've developed this webinar series in partnership, and we're very excited to be working with them. Shilpa, do you want to take the floor?
Hi there, this is Shilpa Sankran with the Net Zero Energy Coalition. Thanks, Alyssa, and thank you, Sonia Winkleman, our former executive director, for pointing out the technical issues we were having. I'm going to keep this brief as well because we're running behind a bit here, but a little bit about who we are. Our coalition was formed in order to accelerate market adoption of net zero energy buildings, and we've expanded over time throughout North America, and we really handle across the board residential, commercial, community level net zero energy because we believe in the power of collaboration across the industry to accelerate adoption. And our role in the industry is to bring together all of the experts who are doing great work. We recently did a study through Natural Resources Canada and discovered that over 130 organizations are focused on net zero energy across North America, which is a fantastic thing to learn, but it presents an opportunity for us as well to bring the efforts of these organizations together to become more effective. And it's under a framework called Collective Impact, which some of you may have heard about. And as such, we are partnering with Build It Green to deliver these webinars. We think we can all do more efficiently and more effectively if we combine efforts. So we also, in addition to webinars, we host an annual summit, which this next one will be in March in Boston, March of 2015 in Boston, in collaboration with the Northeast Sustainable Energy Association's 2015 Building Energy Conference, and that brings together about 3,000 industry professionals, and we'll be a piece of that. And our goal is to bring together the leaders in net zero energy to talk about what we need to do to continue to drive market adoption. And one of the big important things is sharing information among the innovators and the early adopter group, who don't always necessarily traditionally communicate with one another. And The Young Properties is one of those innovators that took this on early on, and we hope to get their information and all these other builders in this series out to the industry so it is easier for all of you to build net zero projects. And the exciting thing about the Young in particular is that they're production builders. So the work they've done is not intended to be demonstration or solely demonstration, but really to scale and to see how production builders everywhere can do this at the right price point, at the right marketing, the marketing model, and to ensure that overall the business feasibility can be maintained with net zero energy. So I'm excited to present Brandon now to go ahead and give us his story.
Thanks, Shilpa. So for those of you who had any further questions for myself, here's my email. You can reach me at training@buildthegreen.org. Likewise, Shilpa's email is listed on this screen, and we can display this at the end. Also, we can follow up in an email at the end of the presentation. And also, I should make clear to anyone on the line that the slides will be available for review after the presentation, and we will send a follow-up email. So with that, I'm going to switch this over to Brandon, make him the presenter, and he will guide us through his experience with Zero Net Energy.
All right. Let's see here. Let me click that. Can you see?
Yes, I can see him.
All right. Well, thank you guys very much for the introduction, and I'm definitely excited to participate in this and very honored. So thank you guys very much for asking me. So we have sort of a humble story. You know, we're a family-owned, family-run company. My management team consists literally of my family of 5 and our CFO. So, you know, it's a little bit of a different story from, you know, a lot of the ZNE projects that you may hear about. And because of all that, that's kind of really the focus that we took when we decided to go down this path. You know, how do we, you know, how can a smaller, you know, mid-sized production / semi-custom, you know, builder attain zero net energy in a cost-effective way and in a way that makes sense in the construction side of things. And so that was really kind of our ultimate goal. And why don't I start by kind of showing you how the home ended up kind of turning out. Ultimately, we actually ended up building a zero net energy home, and that's really what this all is coming together to show you. So let me close that. So let me go ahead and jump over. Here's a quick picture of the exterior of our zero net energy home. And it's our residence 205. Italianate elevation, so you can see it has a real clean stucco look with painted pop outs around the windows and extended archways. Your typical sort of S tile on the top to bring it into the Italian sort of style. And then you also notice we went with a drought-tolerant front yard landscaping, and all that lawn is actually synthetic lawn, which turned out really nice. So not necessarily energy efficient on the drought-tolerant side of things, but it kind of goes along with the whole idea of sustainability, so we thought it was a good idea. But either way, here's sort of the broad overview of how the home ended up turning out. And as you can kind of see, if you look at any of our other homes, if you go to our website, you'll see it looks actually exactly like one of our normal homes. It's just as beautiful as our other homes, and that was our ultimate goal, was to build something that, I'll show a couple of interior shots too, was to build a home that's not like way overly contemporary, that, you know, people in our area aren't going to want to even buy, that looks to be like a niche thing. You know, our goal is to build a really elegant home and build a lot of them, and that's who we are and that's what we do. And my family's company, I'm a third-generation builder in my family. My grandfather built 17,000 homes in the Fresno area, and then my parents kind of took the torch on, and we now have our own company. And 2014 actually marks our 40-year anniversary, and our company has built 7,000 homes in the last 40 years. So, it's a real honor and to kind of continue this this approach, building an elegant home and building a lot of them and really helping our community. So really, focusing on just sort of a one-off, custom, really modern-looking design, like you may see here, is not really what our goal was. It was to build something that was really elegant. As you can see in the master bathroom here, it's modern design, but still very elegant, and that's kind of what our goal was. That was kind of in the back of our minds while we went through this whole project. So here's sort of our path of what I'm going to talk about today. The bottom left circle is our path to zero net energy, sort of a little brief timeline through the years of how we got to here. What were the challenges once we decided on a design for zero net energy? That's the next circle there. After that, what were the actual sort of specifics, the specifications and the cost involved for the actual Z&E project that we built, and what's next? So let's go ahead and jump into the middle here. And so our Z&E home was designed to produce as much energy as it consumes each year when accounted for at the source. And bear in mind, that wording right there was actually very, very carefully worded. You'll notice the word designed. And you're going to see that word and the word estimated a lot, sprinkled in a lot of the any of the marketing materials that we ever talk about. Any of this type of stuff is designed and it's based on estimates. Those are really, really important things that we as a builder, as we started down this path of highly energy efficient homes and zero net energy design, that we realized those were important things so that we didn't somehow overpromise and get sued somehow. I mean, it's an important thing as a builder to make sure that we deliver what we're trying to deliver, and so that's that wording that we have there. It's designed to produce as much energy as it consumes each year when accounted for at the source. We can go in, for days talking about the different definitions that are out there and why we chose the one we chose. But maybe at the end, if you guys have more questions about that, we can go deeper into that. Our homes use both electricity and natural gas, and so when you hear the source, that's basically what we mean. We're offsetting the electricity at the site, basically, but the natural gas, we're accounting for it at the source and offsetting that indirectly by overproducing electricity. So again, we can go into that later if we want. So this home is now a concept home in California, Clovis, California. And Clovis is basically a little bit of a smaller sister city right next to the city of Fresno, which is where we're based out of. Most of our development goes on in Clovis. And it was completed in late 2013, last year. So it's a model home. It was built as one of our 3 new model homes in Clovis, and potential buyers tour it daily. So let's jump over to the path we took. Well, 2009 was when my brother, who is 4 years older, actually started with our company full-time. And with a sort of fresh blood and innovative, perspective on things, he started realizing that the energy efficiency and sustainable side of construction was becoming a big deal, not only just for the industry participants, but also the consumers. And especially here in the Central Valley, where temperatures really fluctuate. I mean, we're probably going to hit 100 today. We've been in the hundreds for the last few months now. It's been really brutal, and so the temperatures here reaching in the hundreds means that people's energy bills are going to be really high, obviously, and therefore, if you can build a really energy-efficient home and sort of differentiate yourself from the rest of the pack, as we have done, you're going to be able to capture a different part of the market. And so that's kind of what our goal was when we started in 2009. We looked at the Build It Green Greenpoint Rated program, as they already kind of talked about a little bit. That seemed to be sort of the best fit for a company like us. You just had to meet a number of criteria to meet their minimum requirements of being Greenpoint rated, and we did that really pretty much with ease. A lot of the stuff we already realized we were already doing. And then the energy efficiency requirement was to be at least 15% better than what the California Title 24 Energy Code required. And I apologize if you hear some drilling. I was afraid of this. They're doing some TI tenant improvements below me, so hopefully that's not too distracting. So 15% better than code, and so we, again, that with ease, because it was really just a matter of taking stock of what we already do, and at that point it was just a matter of kind of increasing the efficiency of some of the products that we already install. So using some better windows from the same manufacturer, using some more efficient heating and cooling equipment, using more insulation up in the attic, and so it was fairly easy to get to that. And so, well, we wanted to continue the ball rolling, and so we went to the next year, 2010. We figured, okay, well, what's the next step? Well, we got more points on the Green Point rated scale, and we decided to up our energy efficiency from 15% minimum of all of our floor plans to a minimum of 30% better than what code requires. And even that was really pretty easy. It was still just a matter of upgrading the efficiency of your equipment, using better windows, using even more insulation in the attic, things like that. It really was not too terrible. However, the main problem was the cost. And as always, whenever you talk to a builder, if you're going to talk about some special projects, they're going to want to know what's the cost involved. Because as a builder, we're a for-profit company, and when it really comes down to it, we need to be able to make a profit. And so if the financial feasibility side of things doesn't work, then the whole project doesn't work. So it did cost a lot more, thousands of dollars. However, we also entered into the program California Advanced Homes Program. Sorry for being redundant there, but the CAHP program, CAHP. And that's really the main rebate organization here in California for offsetting cost of building better than what code requires as far as energy efficiency goes. So the CAHP program, we've been in that for a long time, and it's really, really made this possible, made being able to build better than code possible, because it's helped offset a lot of the cost that it takes to get to that. Not all of it, but a lot of it. And the remaining amount we kind of attribute to that sort of edge that it gives us, and it still ends up being worth it for us. So we've continued to try and better ourselves. And so the next year after 2010, we get to 2011, and what was the next goal? Well, the next goal was, now that we're building really energy efficient, how do we get to zero net electric? How do we try and offset the home's electric bill? And as you can kind of see here, the trend is sort of taking baby steps. As a production builder, it's really important not to just like try and jump in and try something out, especially if you're going to be doing it at scale. If you, let's say, try something out and it has a little bit of an issue, now you've got a big issue, because it's going to be multiplied throughout all the other homes that you're going to be doing it for. So we kind of take the baby step approach. And in 2011, we got to zero net electric. Really, at that point, it was just a matter of, and this was being offered to our home buyers as an option, as a way of upgrading their home. And really, all it was adding a specifically sized solar system to the home to offset the estimated, and there's that word again, estimated annual electrical consumption of the home. And since our homes were already really efficient, it didn't take too much to get to that level. And so that was kind of what we were at that point. And by offering that as an option, we ran into a problem. We actually didn't sell a lot of that. And the problem was the cost of the solar. We were only offering solar as purchased, to be able to be purchased at that point in time. And the main reason for that was we were hearing about some of the lease products out there, but we were pretty nervous about them. There was a lot of terms involved, and we were worried that our home buyers would run into an issue down the road, and then ultimately we would get sucked into it. And so that was kind of the main reason we didn't go with the lease up front. But then we ran into the issue of no one wanting to buy the solar because it costed so much. And at that point in time, around 2011, down in the downturn of the economy, people were having trouble just coming up with a down payment for the home. And so coming up with, $30K or $25K for the solar system was really not much of an option. You might say, well, couldn't they add it to their home loan? Well, the problem with that was that the appraisers were not giving enough value, and they really still are not, at least in our area, giving enough value to solar systems that the bank would allow it to be added to their home loan. So, for example, let's say they wanted to do the Xenia option. It costed $30,000 for that solar system. The appraiser would probably only give it about $5,000 value, that far off. And so they would only be able to add about $5,000 of that to their home loan, and the difference, the $25,000, would have to come out of pocket cash to pay us to make it whole. And so that was really kind of the main issue with that. And so it really was a catalyst for us to begin looking into the leased solar systems a lot more heavily. And you'll see when we get a little bit further along, we actually have ended up implementing a solar lease program, and we're much more comfortable with it now. So 2013, that brings us to our new project, the actual Zero Net Energy Home. The year before, 2012, is when we actually started designing the project. And we started designing it with the PG&E program, and I'm going to be referencing that in a few slides coming up here. And they helped us design, basically adapt one of our existing floor plans into the Z&E design that we ended up with. And this kind of all stems back to what the ultimate goal here was. And the goal was to try and get a production home to meet Z&E at an affordable and effective way, where you didn't have to completely start from scratch and redesign a whole new floor plan, which takes tens of thousands of dollars and like at least 6 months to design and engineer and get approved with the city. So the goal was to try and adapt an existing plan to get to Z&E and figure out how easy and affordable that could be. So ultimately we designed the home, and then it turned into an actual project where we built the home as one of our new model homes in 2013. So that kind of takes us up to about today. And as I already kind of mentioned earlier, up until designing the Z&E home, achieving greater efficiency really was pretty dang easy. It was just a matter of upgrading the efficiency of certain things. It wasn't really a dramatic change in the design or the structure of the home. However, once we got to the Z&E project, it was clear that if there was going to definitely be some significant changes in how we built our home to be able to reach that level of efficiency. And so that was definitely an important matter. But as I said, the PG&E Emerging Technologies program that we were within, they subcontracted an energy consulting firm that really helped us out. So I got to give a lot of kudos to Rob Hammond and Bureau Energy for being a really great help on that side of things. And we quickly learned, as I said, that the steps to get to Z&E would definitely be significant. So along with that, definitely came some challenges, and so that's what I'd like to kind of jump into now. So the challenges, there were two main ones that stuck out in my mind. There were others, but the two main ones that I want to talk about was trying to get our ducts in conditioned space, and then the second one was going 100% LED lighting. So I'll first kind of talk about the ducts in conditioned space here. And ultimately, the main problem with it was that, well, maybe explain first real quickly how we currently design and build our home, just so you know where we're coming from. I would say our approach is pretty typical, especially here in our area. We do a typical blown-in fiberglass insulation on the attic floor, and we do R49 up there as a standard to get us to that minimum 30% better than code. And then our ducts and our furnace and air handler, we use a forced air system with a condenser on the outside of the home mounted on the ground. So the duct system and the furnace and the air handler are all up in the exposed attic, and that's sort of the typical approach. So to adapt to Z&E, we really had to figure out an approach of getting at least the duct system down into the conditioned space of the home. And so what we ultimately decided, we settled on an approach to drop the duct system down into soffits, frame down soffits within the interior space of the home. And the only reason our team was okay with doing this was because we do 10-foot ceilings as a standard feature in our home all throughout the single-story plans. And on the 2 stories, it's the bottom floor. The top floor would be 9 foot. But since this was a single-story home, it's 10 foot all the way throughout. And so we were okay with at least dropping a foot to 9 foot. And we only did that in strategic hallways and rooms. And we were okay with that. And I'll actually show you a picture in a slide or two here of how it ended up looking. But the problem with that was, well, one, it only dropped some of the duct system in a conditioned space, so your equipment still remained up there exposed. And the other problem was when we actually designed it, in theory it sounded good, but when we actually tried it out in practice, we realized that there was going to be a lot more duct system still remaining up in the exposed attic. And so what we ended up doing, and I probably reference this a little bit later, we ended up actually thinking quick on our toes and running some new simulations in the software and determined that if we just buried the remaining ductwork that remained in the exposed attic in just the blown-in insulation, and we buried it in R60 insulation, we would actually have negligible effects on the consumption of the home. So it ended up kind of working out okay on this one. But moving forward, that's going to be a challenge, and we're probably not going to want to try and go with this approach again, but it's still yet to be seen. So we'll see where we go with that. So here's a picture of how it looks in one of the hallways. You can see there's plywood on the top side of the duct system, so that's separating the conditioned space down below from the attic above, and the insulation would be below and on top of that. And then you can see the frame down 2x4s that would enclose the duct system in a little sheetrocked sort of duct chase. So that's sort of an example of how it looks. So in addition to these problems, it was also really labor intensive. Our framers were definitely not used to doing that kind of thing. I mean, we spent thousands of dollars to get them to do it, and to do it in a way that was feasible for the duct system. And it was, as I said here, costly as well. So it's definitely a learning experience. And this is why, really, the main reason why I say is we need to take baby steps, at least as a production builder, because just jumping into something like this, you're going to run into some for sure problems. So it's a matter of running into them, learning about it, and then adapting and going from there. So all in all, I think it was a good experience, even though it was a challenge. So, and as I said here, we buried the ducts that remained in the exposed attic with negligible effects. So. And then the other challenge, as I mentioned, was going 100% LED lighting. And the main problems with this were twofold. The first was availability of product, LED lighting. That may not, automatically be an issue, if you're thinking about it, but you think, well, just screw in an LED light bulb for a fixture. Well, the problem with that is that certain rooms of the home, you're required to do integrated high efficacy lighting. So, for example, the kitchen, the bathroom, the laundry room, for example. So in these rooms, you have to use either fluorescent or an integrated light fixture that has the LED as part of it. And so finding product that was affordable and easily attainable for these types of locations, and I mentioned the LED light kit on the ceiling fan in one of the previous pictures. The ceiling fan is one of the biggest ones that's a problem, and I'll actually go into more of that a little bit later. But either way, availability of affordable and attainable product was one of the main problems. And the problem with that was, the problem for me with that was that our trade partner, the electrician, was just definitely not up to speed on it. They're sort of a little bit of a smaller local mom and pop shop, and so they didn't really have the experience in it, and it was a real learning experience for them as well. So I pretty much had to hold their hand through the process. And again, another learning experience. I think we're much better off now, but it's going to be a challenge making sure that we find an attainable, affordable LED product if we're going to continue to do 100% LED lighting. So here's some more interior pictures. You can see we ended up with some Cree LED, integrated LED can lights in a lot of the rooms. You'll see the kitchen here. We did some LED under cabinet lighting, some LED pendant lights. And again, you can see a really elegant kitchen design. Here's the great room and the dining room and the kitchen in the background. There's that ceiling fan I talked about. To this day, this is still the only ceiling fan that I've found that has an integrated LED light kit that looks really elegant and would work for a home like ours, as opposed to being really overly modern and contemporary. A lot of the ones almost all of the ones I found are just way too contemporary and just don't work. And so, availability of product is going to be, concern going forward. So. Here's the dining room. What worked well with this light fixture, the hanging fixture here, was we actually offered this exact same one already, and we found that they actually offered an LED version of it, and so that one actually was a really easy one to do. So, all right, so the specifications and the costs, which I'm sure a lot of you guys are excited about. I'm going to zoom into the top part of the spreadsheet here, and then we'll jump down to the bottom. So the top part talks about the envelope and our heating and cooling system. The second column there, you're going to see it says current DeYoung design, and basically what that is how our homes are currently designed to meet the 30% minimum better than code. And so you'll see that R49 in the attic. You'll see we use radiant barrier roof sheathing for our roof systems. Our wall cavities have always been 2x4, and so again, the main project here was to try and adapt our existing plans and not redesign. And so we actually stuck with our existing 2x4 walls. We're able to get some high-density R15 bats in there. And we also use a rigid insulation board on the exterior of our home before the stucco goes on, and that gets us another R4. So we're almost about R20 with the wall systems. We do a lot of testing on the home, so QII, quality installation, insulation installation. You'll see a lot of testing down at the bottom for the heating and cooling system there. Let's see, there's a line item there, exposed thermal mass. And we don't really normally take that into account at all with our existing plans. But for the Z&E home, we actually did try to use a passive technique known as increasing the thermal mass of the home. And basically what we did was add a tile floor in some bedrooms, the master and a secondary bedroom, that were on the south side of the home. Basically, the reason for that is to utilize the passive heating of the sun in the wintertime. So in the wintertime, when sun's coming into the windows of the south side there, it's going to hit that tile floor, and and it'll heat the foundation below much easier than if you had carpet there, which would normally probably insulate the concrete. So with tile flooring there, it's going to heat up that foundation, which is also known as your thermal mass in the home. And then at night, when the sun goes down, it's going to now radiate back into the home from the foundation and help heat the home. Therefore, you don't have to use as much natural gas to burn through furnace. And so we utilize this technique here, but just bear in mind, we don't usually use too many passive techniques with our homes, and the main reason is because as a production builder, your lots face all different directions. So if we wanted to, make this a standard spec in our Z&E plan, well, the home might not end up facing with those back rooms facing south. And so these types of passive techniques, while I love them and I think they're great, especially in a custom, situation, when you start talking about production level stuff, it gets to be a challenge. So in this home we used it, and it worked well. But going forward, it's going to be a challenge trying to utilize that. So you'll see the envelope leakage. We built a pretty dang tight home, not extremely tight, but again, we're trying to do things affordably and feasibly for production scale. The windows are really, really great windows, really low U factor in SHGC. The cooling system, we normally do a 16-SEER, 13-ear. For this home, we bumped that to a 19-SEER, 14-ear. So a really great system. We use Linux in case anyone's interested. Again, there's a bunch of testing in there, just verification testing. The furnace is a 96% natural gas furnace, and we stuck with the same one since it's already so efficient. Duct filtration, obviously, as you can see, normally in the exposed attic. For this one, we went with conditioned space as much as possible. Duct leakage, we're at less than 6%. I think most of ours are around 4 or 5% on average. And and there's a bunch of other testing that we do there that we already do. And then water heating, lighting, and some other energy efficiency stuff, and obviously the solar at the bottom. So water heating, we normally do a gas tankless heater. That's a 96% efficient tankless water heater. For this, though, we wanted to get, actually it's a 95, but I think it's actually 96. For this, though, we wanted to, keep the ball rolling and trying to improve it even more. And so we went with a heat pump water heater. Now, granted, we really like the tankless because it's endless hot water, and people really love that comfort, type of thing, of knowing you're not going to run out of hot water. But we wanted to go with a heat pump water heater, and so we went back to the tank system for this particular home. And since the energy factor on these things is just through the roof. And then we also went with a hot water recirculation system using a demand pump. And what that did is not necessarily an energy saver, but it's a water saver. Again, sort of all in the same realm of sustainability. And that basically recirculates hot water to each fixture whenever there's motion. And we have little strategically placed motion sensors in the bathrooms. So that way you're not turning the hot water on and waiting for hot water to get there while you're wasting water down the drain. So really cool system. Lighting, as I said before, we went 100% lighting, LED lighting rather. And we normally do probably about 75% CFL in like the kitchen and bathrooms and laundry, and then some incandescent throughout the rest of the home. So this one, it was a significant jump, as I already kind of mentioned. So Energy Star dishwasher cooktop is gas, as I mentioned at the very beginning. Normally we have the standard clothes dryers, electric, but you have an option to do gas if you want. And then we also installed an e-monitor in this home, and that basically gives us the ability to monitor minute by minute, circuit by circuit, how much electricity this home is using. And so I'll actually show you how that looks in a little bit here. And then the solar system. We went with about a 6 kilowatt system, and it's a prepaid lease system through SolarCity. And let's see, what time are we at here? 11:15, so we got a little bit of time. I think I'm doing okay here. So, and as I mentioned before, the lease system, we were nervous at the start, and here's an example of one of the main reasons what we were nervous about. You hear about how the lease systems have credit terms, and the buyer has to qualify for the lease. Well, we were thinking, well, let's say our homeowner qualifies and they get it, and then years down the road they want to sell their home. Let's say the new homeowner, the subsequent buyer, can qualify for a home loan to buy the home, but they can't qualify for the credit terms of the solar system that's on the home. Now what do you do? Now you're running into these problems where our buyers, our original buyers, are saying they can't sell their home because the person can't qualify for the lease. So there were problems like that we were really nervous about to start. But as time went on and we started talking with companies like SolarCity, we found solutions to all of these issues. And especially when we heard about the prepaid lease. With a prepaid lease, as the name implies, you're literally having all the 20 years of lease payments paid up front. And by doing that, since it's not a purchase and it's a lease, it's way more affordable than a purchase. And therefore, as you can see here, it's only about $5 grand for that system size, almost $1 a watt. And the appraisers were not, we were not having much issues, getting this figured into home loans or people if they just wanted to pay cash for it. So that made way more sense and made it way more affordable to, first of all, attain zero net energy, and two, for buyers just to get solar in general, even if they weren't getting to Z&E. So all in all, energy efficiency measures and the photovoltaics, we got to about 18 grand. And that brought us from 36% better than what code required for our standard home to 65% or so better than code. And that 65% was pre-photovoltaics. So that's just taking into account energy efficiency. Obviously, getting to Z&E, the goal is to get around 100%. So, all right. So some more pictures from the exterior of the home here. You can see that white rigid insulation board that totally encapsulates the exterior of our walls. You can see they tape the joints really well, so that really helps with indoor air leakage. When they tape it up like that, it helps with the leakage. And then here's the picture of the radiant barrier OSB material that we use for the roof systems. And that helps keep the attic system, the attic interior, I think they say about 20 or 30 degrees cooler in a really hot summer day than it would have otherwise. So that really helps. We do the R49, as I said, in the attic. For this one, we did R60 in a lot of the areas so that the ducts were fully covered. And then here's that heat pump water heater. It's the Rheem hybrid heat pump system. And so that whole top portion with the vents is basically where the heat pump is, and is able to extract the heat out of the air around it and heat the water, as opposed to having to use a lot of natural gas or electricity to heat the water. Here's another shot of the furred down ceiling in the entryway so that the ducts could get over to the kitchen. And so the sheetrock would attach to the underside of those little 2x4s there, and essentially covering it up so you don't even see the duct system. Here's another picture of the master bedroom. You can see the tile flooring in there to increase the thermal mass of the home. So that, and you can even see the sun coming in, trying to warm up that ground. So. And then there's that another one of the ceiling fans. We use it both in the master bedroom and the great room. It's got an LED integrated light kit on it. Still, to this day, one of the only ones that has an elegant design that has it integrated. And then here's a picture of their interior hallways. I'm not going to go too much into this because we don't have much time, but we use some motion-activated night lighting in the hallways. And actually, here's an up-close shot of the hallway step lights. And then in the master bathroom and the secondary bathroom, we use some toe-kick strip lighting. And you actually see it's an amber color. And the reason we use an amber color is because it has the absence of the blue color wavelength. And by doing that, it fosters melatonin levels in your brain. So if you're using it as night lighting, it'll help keep you in a sleepier state. And so it doesn't blast your eyes with really bright and fluorescent lighting that would help wake you up, actually. So it has the opposite effect. It helps keep you sleepier if you're going to go to the restroom or get a glass of water at night. All right, so what is next? Well, right now we've been monitoring the energy data of the home over the past, I guess it's been about 6 or 8 months now. And we've been doing it 3 different ways simultaneously. The first way is using the eMonitor that I mentioned earlier. And what I'll do is I'll jump over and show you a screenshot of what it looks like on the web when you log in. So the top half, I'm going to zoom in at the top half here. You see the utility meter. So what is the actual meter showing at any given time? During this screenshot, we were producing 3,700 watts, and we were only using 2,800 watts in that little gray rectangle. So we were offsetting all of the energy use at that given time, and therefore the utility meter was actually going backwards 800 watts at that time. And obviously that's great to see. That's what we want to see most of the days when we're producing electricity. And you can see on the right there the circuits that are all listed, what are actually using energy. You can see the AC unit. That's obviously going to be your biggest user, especially in summertime. And then most of the rest of it was lighting. The furnace, I think, is really just the air handler. So even when the furnace isn't actually burning, the air handler is still part of that same circuit, I guess. And so that's pulling electricity as well. Let's jump down the bottom here. This is a really cool way to visualize your production and consumption on one graph. So the blue is your production. You can see it ramping up around 8 a.m., getting to a peak around 2 p.m. and then starting to taper off. And then you can see it completely, covering your consumption there in green. And you can see all the spikes there when the AC system turns on. And we actually use what's known as an ECM, and that's an electrically commutated motor for the air handler. And basically what that means is it's a really way more energy efficient air handler system. And so these spikes would be way higher if we weren't using an ECM. I think we use like 30% of the electricity of what a normal fan motor would be using. So it's good to see that these aren't as high as what a normal motor would be using. And then you can even see the temperature of the exterior temperature. So pretty cool graph, great way of seeing the consumption of the home. We also have a third-party PG&E through the program we did with them, subcontracted the energy monitoring through a different company, and it's actually Davis Energy Group that's monitoring this home. So they have all their own sensors throughout the home, monitoring their own circuits and everything, and so they're monitoring that on their own as well. And then I also get the energy bills that come in, the net energy metering statements, and I put together my own spreadsheets based on that. And I'll jump over and kind of show you what that looks like. So I put together a little Excel thing. I'm really nerdy, so these numbers kind of get me excited. All the black is actual data, and then the red are upcoming months that we haven't filled in yet. You can see the consumption of electrical kilowatt hours there in that first red square, and then the actual cost of the electricity. There's the monthly minimum charge you get. If you have solar, you have to pay that every month no matter what. And then there's the charge or credit that you get. So obviously, as you can see, every month except for the very first one in January has been a credit, and then it's been accumulating in that net column there. And then I also monitor the gas usage. So as this is a model home, obviously the numbers are not going to match up for sure compared to what an actual homeowner is going to be using. But we're taking that into account as much as possible when we're, so basically we're taking the energy results with a grain of salt, and we're trying to factor in as much as possible what actual consumption would be for a homeowner if this was a homeowner's an actual owned home versus a model home. And so as you can see, a lot of data here. So and almost lastly here, what's the next step from there? Well, we're going to improve the design. As I said, the ducting condition space has been a real challenge, and so we're continually working on different approaches. There's tons of different ways of doing it. You can do away with ducts altogether and go with a mini split system, and there's pros and cons to every single approach that I've heard. And so it's unfortunately there hasn't been one silver bullet for this this approach, or rather this technique. And so we're gonna continue down that path and see what we can come up with and test out different approaches until we can find the right one that makes sense for a production scale in an affordable manner. So. And then lastly, well, once we figure that out, the next step is to continue building more Z&E homes. And so we've already got one in the works that we're going to do with PG&E again. But then the next step is, before we do that, is to make sure we get ducting condition space and these other design components figured out. So that's sort of the main overview of our path to zero net energy. A lot of information, so hopefully you guys didn't just glaze over and it was interesting a little bit. And so just want to thank you guys for listening in, and if you got any questions, feel free to let me know. My contact info is right there. So.
Thanks very much, Brandon. We do have a couple of questions that came in, so I'm going to go ahead and read these. I'm going to leave the presentation mode with you, though, so I'm able to kind of read them out at my own pace and hold them, keep them all open on my screen. So for those of you who had questions throughout the presentation, please submit them now. I'm going to start reading. So the first question we've got is, did you consider using energy recovery ventilation?
It's a good question. We actually used to use ERVs when we, actually probably about 12 years ago, and then up until about maybe, 4 or 5 years ago, actually maybe even 4 or 5 or 6 years ago, we actually decided to change the approach as far as ventilation goes. And what we decided to do, as I kind of mentioned earlier, we use an ECM. And so part of the function of the ECM motor is actually to pull in fresh air, and then it filters it before it gets induced back into the forced air system, where it supplies all that new fresh air. And then what we do is we have a continuous laundry bath fan that goes. It's intermittent, but they say it's technically continuous. And so by using the ECM, we felt the cost benefit. It's it's a little more affordable, but the benefit in the energy savings actually made more sense. Some people might say, well, with the ERV, you're actually saving energy as well because you're recovering that energy. Let's say in the wintertime, you're exhausting hot air and you're able to recover that heat as opposed to just letting it all go. Well, in our simulations, we actually felt that with the cost involved with ECM compared to the ERV and the energy savings with the ECM motor, when we're running that in the summertime with the huge savings that we'll get running the air conditioner, it actually made more sense to go that direction. So that's really the way we go. We exhaust with a continuous bath fan, and then we bring in filtered fresh air through the ECM. So.
All right, and the next question we have is, are you tracking the home to see if it's truly net zero?
Yeah, so they might have asked that question before I kind of showed these types of things, these graphs here. The graph on the bottom is electrical consumption. So as you can see, the red line is 2014, considerably below in the summer months. And that's just, again, probably mainly because it's a model home. There's offsets, though. Because it's a model home, we use way more lighting than your average homeowner. Like, every single light in the home is on almost, the whole day. And then a lot of it is even on still at night so that it looks nice and lit up. But at the same time, it's probably not, using quite as much, they're not cooking, they're not using laundry. So we're doing our best to monitor it as close as possible. And like I said, trying to, take into account if it was, actually lived in by a homeowner, how far off does this look? So, I think we're pretty close based on, it being a model home versus actually lived in. So, but yes, the answer is yes. So.
Right. Another question, did you consider using a heat pump for space heating?
So as far as heating and cooling for the home, we talked about all kinds of different approaches, but as I kind of said at the very beginning, our main goal was to design a home that was that made sense for us as a builder, that wasn't like too much of a learning curve, that we would still be comfortable eventually selling this home to someone, and that someone would actually have to live in it. Well, not have to. they would feel privileged to live in this home. But so that someone would actually be able to live in it and not have any issues. And we've the forced air split system that we use is what we've always used and what is very traditional in this area. And so we didn't have that experience with heat pumps. Moving forward to our next Xeni home, I've looked a lot more into that, especially because now if you do a heat pump, mini split system, that way you get away from ducts altogether, and that might solve the ducts and conditioned space issue. But there were a number of issues that that came up when we discussed that idea. One is our HVAC experts said that the cooling and the heating is always, the performance of it with heat pump technology is never really quite as good as your typical forced air system. For example, they would say in the wintertime when you're trying to heat the home, the air is probably coming out at maybe 85 or something like that, versus if you have a typical gas furnace, like our system is coming out at 110 or something like that. So it's able to heat and cool way faster, and so the occupants will be much more comfortable generally. I don't know. There was a number of challenges. If you go with a mini split system, you have these kind of somewhat obtrusive indoor head units that have to be mounted on the wall. It wasn't until after we built this first Xeni home that I actually heard about some cooler new ones that, first of all, there's some that look better than the typical ones that I've seen. They have like a designer series that Fujitsu has. And then there's also stuff that I've heard about that's called slim duct, and they actually get built into like a furred down ceiling like we did for the duct system. And you would kind of build it into those, or even walls. I think they can stand up vertically. So I've been looking into this stuff more and more, but it's all about the cost benefit. I'm trying to weigh the cost as I hear these types of systems are typically more expensive. So, there's just tons of challenges to every type of approach, and I'm trying to stay open to all of it. But that's where we are at right now. We've looked at it, but we didn't decide to go with it for this one. So.
All right. Then we've got, are you looking at the embodied carbon footprint of materials at all as part of calculating zero net energy?
So I like to tell people that I know a little about a lot of things, and I know a lot about a few things too. But I definitely can't answer that myself. However, I do know that, yes, that's taken into account, but not by me, someone much more smarter than me. In fact, I mentioned his name, Rob Hammond, who's a PhD. He definitely ran all that analysis for us. And I mean, hey, if you wanted to see a really complicated spreadsheet, he could show it to you. But basically, yes, it was factored in. But whether it reached specific carbon footprint of 0, completely neutral, I'm pretty sure he would say yes. But I don't really have those details off the top of my head, unfortunately.
All right, thanks. And also got another consideration. Did you think about extending the insulation into the rafters to condition the attic space?
So great question. And yes, that was definitely one of the potential approaches that we've looked at. This first Zini home, we didn't really branch out too much because we needed to start somewhere. And as I said, we try and take baby steps. And so for the first particular one, we didn't feel trying to insulate the underside of the roof deck, and doing like a sealed, unvented attic we felt it was too much of a jump, at least for the first home. But moving forward, that is definitely one of the approaches we're looking at. And I will say insulating the underside of the roof deck and doing a sealed attic is probably the front runner in one form or another. There's a bunch of different ways of even doing that type of technique. You can use spray foam insulation, so it just sticks to the underside of the roof deck, but that is way more expensive. And so again, cost benefit. I'm trying to weigh all of that at the same time here. You can use some sort of netting and then blow in your typical fiberglass in between the bays, but then you might have a thermal bridge wherever one of the truss top cords is. So then do you hang that netting off so that you can fill in around that? So there's tons of different challenges involved in trying these different things out, and none of them are really. Again, we're a production builder. We're going to be able to do this at scale. So finding an approach that will work well at scale is the key. And there really doesn't seem to be, as I said, a silver bullet for this ducting conditioned space. But that was definitely, for sure, one of the approaches that we're looking at. So.
Great. And then it looks like we don't have any more questions, but there was one suggestion from an attendee that you install the supply boots on the upper level of the interior walls to minimize the duct runs and keeps them in the conditioned space.
So if I understand correctly, I think he's saying have the supply registers for the heating cooling system on the walls rather than in the ceiling. And basically that is what we did for this one by having the duct system drop down into the frame down chases. Wherever they terminate into each room, they actually terminate into the wall, basically, at the upper part of the wall. So, like I said, that got a lot of the duct system down to the conditioned space, but just the way the split forced air system is designed, we had to still have some of the duct system remain up in the attic, and so it was unfortunate the way that had to turn out, and I'm sure everyone has their silver bullet that they think is the way, and I'm trying to be as open-minded as I can, but there's just challenges no matter what way you turn, unfortunately, it seems. So I'm confident we'll find an approach, but I definitely appreciate his comment. So
great. Well, that's all we have for questions. So I think with that we can end the webinar. And just as a reminder to the folks on the line, we will send out a follow-up email, and you will have access to the slides from this presentation. And we'll likely post the recording of the webinar on our website if we get Brandon's permission on that.
Yeah, absolutely.
So, okay, great. Thanks, Brandon. And thank you again this is a great presentation, and I think people on the line really got a lot of it. Got a lot out of this, so thank you.
Awesome.
A lot of compliments coming in on the comment sheet that you can look at later.
Awesome. I really appreciate that.
Yeah. Thanks everyone again, and we'll hopefully see you online again soon.